Hi, everyone. Welcome to our webinar. My name is Kasia Proctor, and I am the Director of Marketing Communications here at Biolog. I will be your moderator today. Our webinar today is titled Optimizing Conditions for Growing and Profiling Gut Microbes with Biolog's Anaerobic MediaMatcher and PreBioM plates. First, I have a couple of housekeeping items. This webinar is being recorded. I will be sharing the link to the recording with everyone who had registered. So that will be coming out probably tomorrow. Please submit your questions if you have any questions through the Q&A chat feature that you should see at the bottom of the screen. Some of you submitted the questions during the registration. We'll do our best to address those either during the webinar or at the end, time permitting. Okay, and now let me introduce our speaker. Juan Sanchez is our consumables product manager. He is a former Stanford scientist. He co-authored several gut microbiome publications featured in Nature. Juan, please take it away.
Thank you, Kasia. Good morning, everyone. I'm Juan Sanchez, the Consumables Product Manager at Biolog. And today I'm excited to show you how the Anaerobic MediaMatcher and PreBioM plates combined with our Odin instrument can help streamline your microbiome research, particularly when dealing with those challenging obligate anaerobes. Our agenda for today is as follows. I'll start with an overview of the gut microbiome, including a look at various omics techniques currently employed by researchers. Then I'll present the Anaerobic MediaMatcher plate and its capabilities. Once we've covered the basics, we'll dive into a case study demonstrating how Anaerobic MediaMatcher and PreBioM plates can be used to compare 6 obligate anaerobes under consistent conditions. Finally, I'll summarize our key findings and answer questions. But first, here we see 2 scientists looking through a microscope, and one remarks, "The anaerobic ones are just sitting there, but the aerobic bacteria are doing jumping jacks, sit-ups, leg lifts. It's crazy." I'm sure you've experienced this in your microbiome studies with aerotolerant bacteria being really easy to analyze. Well, it seems the obligate anaerobes are just sort of inert, but I can assure you, anaerobic bacteria which thrive in oxygen-free environments also exhibit important behaviors, metabolizing a broad range of substrates and making contributions to the gut microbiome. These contributions are just harder to observe due to the challenging conditions under which obligate anaerobes grow, which encompass not only low oxygen, but also highly specialized media formulations which are needed to support them. So this misconception stems from the difficulty in studying them in a standard lab setting, which we will try to solve in today's webinar. Let's start with prebiotics, which can come from fermented foods like kimchi, or be isolated molecules like inulin. These provide energy, metabolic substrates, and essential micronutrients that selectively nourish beneficial bacteria, such as those found in probiotic supplements. Prebiotics also happen to be the substrates in Biolog's PreBioM plate line, which contains over 90 of them to facilitate microbiome studies. Prebiotics support probiotic microbes throughout the body, including the skin, mouth, and gut. In the gut, prebiotics and probiotics work synergistically to maintain a healthy, balanced microbiome. The microbiome plays a crucial role in the host's health, from influencing drug metabolism, acting almost like an additional liver, to regulating neurological conditions through postbiotic metabolites produced by probiotic bacteria. These postbiotics can travel throughout the body and impact various systems. When studying the gut microbiome, it is particularly important to note the uniqueness of various regions like the large intestine, where oxygen levels are extremely low. Oxygen-deprived environments are typical in the deeper regions of the gut, especially the cecum and distal colon. In these areas, the absence of oxygen allows obligate anaerobes such as Bacteroides to dominate and play important roles in digestion, fermentation of dietary fibers, and production of essential postbiotic metabolites like short-chain fatty acids. These highly specialized bacteria are far less common in the small intestine, where oxygen levels are higher, highlighting the gut's complexity. A range of omics techniques are used to study the gut microbiome, from genomic methods like NGS and 16S to transcriptomic methods and proteomics, as well as metabolomics, which rely largely on NMR and mass spectrometry. As we go up the ladder, there are more regulatory mechanisms, meaning that a change in the genes may not correlate with the phenotype. Fortunately, at the end of this chain is phenomics, which is the terminal output of all of the regulatory mechanisms within the cell and what biolog assays measure. Now, from my point of view, no omics approach is complete without phenomics data serving as the final output and capturing all the complexity within a cell. Our phenomics technology for studying obligate anaerobes revolves around monitoring what substrates a microbe consumes and how efficiently it turns those substrates into biomass over time, employing kinetic OD measurements to achieve this. By looking at extracellular properties or phenotypes, we eliminate much of the biological noise, focusing only on what's relevant for our cell of interest. We combine this technology with Odin, a high-throughput solution for dynamic incubation and measurement of up to 50 plates. It is also offered in a smaller 8-plate version to accommodate the user's needs. And it is supported by its own intelligent software, which computes multiple parameters for kinetic characterization and comparison. This results in more robust and actionable experiments. Our microbiome analysis platform leverages the power of Odin, integrated with PreBioM plates, phenotype microarray PM plates, and anaerobic MediaMatcher plates, offering a comprehensive and advanced solution for in-depth microbiome research. Incubation and kinetic data collection of anaerobic microbes, facultative anaerobes, and even obligate anaerobes is supported on Odin. Additionally, our platform supports community analysis, a critical component needed to understand the interactions such as cross-feeding between constituents of the gut microbiome. All of this can be done at high throughput, delivering easy to interpret, streamlined reports for seamless analysis. Now that we covered the basics, let's look at the anaerobic MediaMatcher. As mentioned earlier, culturing obligate anaerobes, such as those found in the gut microbiome, requires extensive media optimization. The anaerobic MediaMatcher microplate streamlines this process by offering 42 preloaded biolog synthetic media formulations and 5 widely used commercially available options, enabling efficient testing and identification of optimal growth conditions. The plate is divided into top and bottom sections, each with 2 equal halves, allowing for various modes of operation and enhancing the efficiency of gut microbiome research. Key features include a simplified media selection platform with 47 formulations to test. It is efficient and cost-effective, helping researchers avoid months of designing and building testing media recipes in-house while struggling with quality control issues associated with small-scale production. There's also no investment in liquid handling equipment to reproducibly prepare large volume of assays. Chemical waste is also avoided, not having to purchase over a dozen chemicals to prepare numerous media permutations, when in the end, only a handful of the chemicals will be used to prepare an optimal media for larger scale experiments. This time and resources are better invested doing the actual research. It is adaptable, having compatibility with single isolates or communities, and leverages the sign of experiments principles to cover a wide range of variables that support the growth of anaerobes. And lastly, it seamlessly integrates with Odin, PM, and PreBioM plates for a comprehensive phenotypic profiling solution of gut microbiome anaerobes. Here is the recommended mode of operation using a single microbial sample. The top half of the plate is inoculated without an added carbon source as a control, and the bottom half is inoculated with a carbon source such as glucose. Alternatively, one isolate can be grown with a carbon source on both sections of the plate to address variability, or different isolates can be grown on the top and bottom to maximize screening efficiency. The 42 biolog synthetic media formulations were engineered by a design of experiments approach, sampling from a diverse range of variables, including essential nutrients, vitamins, oxygen scavengers, and reducers that support microbial growth. Each of the rows seen here represents a different media formulation, while the columns illustrate the components and variation in composition among them, with darker colors indicating higher concentrations and no color indicating the absence of a component. After identifying an optimal media, researchers can order biolog synthetic media 1 through 42 in convenient 500 milliliter bottles to scale up their experiments. This media integrates seamlessly with our PreBioM and PM plate lines, enhancing microbiome research by facilitating phenotypic profiling of new isolates and microbial communities. Here is our workflow. First, a challenging anaerobic microbe isolated from a biospecimen is subcultured on rich agar and plated on an anaerobic MediaMatcher plate within an anaerobic chamber. The plate is sealed and transferred to Odin for 24 hours of incubation and analyses. Kinetic OD measurements are employed to identify the optimal media, in this case BSM7, which meets the researcher's needs by promoting anaerobic growth while minimizing the lag phase relative to BSM33. BSM7 was acquired to replace the standard inoculating fluid specified for the PreBioM plates, enabling metabolic phenotyping of this microbe. The anaerobic MediaMatcher plate is selectable for batch creation using our Odin software version 3.0 and up, and supports the new background subtraction feature, making it easier to go from data collection to insights. Here we can see area under the curve values for two strains, P. sordelli and A. hardis, being compared with the background from the negative control while subtracted. The name of each media appears below the curves for its respective well for easy selection. Here's an example result. On the top half, lacking a carbon substrate, there is no growth. It is also worth noting that the first 5 commercial media wells E through E6 did not provide optimal support for any of the strains tested, highlighting the value of diverse biolog synthetic media formulations. Scientists can have different research goals when it comes to their obligate anaerobes. Differential growth could be desired like on well E9. Or if a synthetic community with all 3 of the microbes growing is desirable, similar growth profiles may be selected like in well G3. The anaerobic MediaMatcher and biolog synthetic media support microbiome plates like PreBioM and PM and can be operated within Odin outside of an anaerobic chamber using our protocols available at biolog.com. The biolog synthetic media replaces PreBioM and PM standard inoculating fluids to enable the growth of obligate anaerobes previously out of reach. Lastly, the plates can be operated at a high throughput in the Odin family of instruments to match the user's needs. Going from an anaerobic MediaMatcher plate to other biolog assays after an optimal media is selected is simple. Just deoxygenate the biolog synthetic media bottle by opening the cap, placing it into the anaerobic chamber via the seal lock process, and allow it to deoxygenate for 24 hours. Then replace the inoculating fluids indicated in the PreBioM or PM protocols. Seal the plate, and you're ready to run an Odin. Here is our case study. 6 obligate anaerobes encompassing commensal, probiotic, and pathogenic bacteria relevant to the gut microbiome will be compared. 4 types of plates will be used for this comparison, including the anaerobic MediaMatcher, PreBioM 1 featuring simple sugars, PreBioM 2 featuring complex sugars, and PreBioM 3 featuring food extracts. The plates will be used in a screening modality with 3 organisms used on each plate and an N of 1. Our anaerobic protocols will be used with incubation and growth kinetics via OD590 being monitored automatically for 24 hours on Odin. Here we can see how the 6 strains performed on the anaerobic MediaMatcher plate. Again, popular commercial media were largely unsuitable to support the growth of all 6 strains. Many of the biolog synthetic media formulations provided variable support, and a few formulations provided optimal support for our diverse set of microbes, including BSM-19 in well G1. Here we can take a closer look at BSM-19, our optimal media, where most strains reach a maximum OD at a similar time. As we can see, BSM-19 supports growth of all 6 obligate anaerobes using a high level of casein, a low level of peptone, high levels of hemin, vitamin K1, and L-cysteine, low levels of sodium thioglycolate, and high levels of BHI. Notably, yeast extract, oxygen-depleting enzyme systems, polysorbate 80, rumen fluid are omitted from this formulation, making it less complex than other alternatives and increasing compatibility with various omics techniques. Next, let's see how our microbes behaved on the PreBioM plate line, starting with PreBioM 1. As a reminder, PreBioM plates are divided into 3 sections, with each section containing the same probiotic molecules. Each of the bacteria is grown in one of the sections across 2 plates, and the sections are denoted by the colored bars. As expected of simple sugars, which are easy to metabolize, we can see lots of growth across the PreBioM plate 1 for all strains. In the purple highlighted region, we can see a notable exception, where one of the obligate anaerobes exhibits minimal growth using 4 of the PreBioM substrates, unlike its counterparts that achieve various levels of growth with these same substrates in this row. Similarly, in row F, we can see Blautia producta and Blautia coccoides using another group of PreBioM substrates better than their counterparts. For PreBioM 2, we can see less growth across the plates. This is largely attributable to the need for specialized enzymes to break polysaccharides into smaller molecules. In row E, we can see B. fragilis being better at using two prebiotic substrates significantly than the other 5 microbes. Lastly, on PreBioM 3 with complex food extracts, we can see various levels of growth with interesting patterns, like in row H, where only Glaucia producta and Cucoides are able to use a PreBioM substrate. Now, let's take a closer look at some of the differences we highlighted. Let's explore the utilization of two closely related prebiotic substrates, beta-cyclodextrin, a heptasaccharide, and gamma-cyclodextrin, a slightly larger octosaccharide. These are niche prebiotics present in the PreBioM 2 plate and are utilized for growth mostly by B. fragilis and P. sordelli among the 6 strains tested. As the B. fragilis growth curve shows, gamma-cyclodextrin is used more slowly than beta-cyclodextrin as it is harder to ferment due to its larger size. For those of you unfamiliar with these obligate anaerobes, P. sordelli is pathogenic, while Bacteroides fragilis is a commensal bacteria, which offers colonization resistance. B. fragilis is able to reach much higher OD levels than P. sordelli, suggesting it may offer protection from this microbe by more efficiently consuming one of its preferred substrates. Next, let's take a look at how our 6 obligate anaerobes use Gentibios, a prebiotic substrate from the PreBioM 1 plate. Here we can see differences in growth by closely related Glaucia producta and Cucoides, with Glaucia producta growing faster and reaching a maximum OD sooner than Cucoides. The two, however, reach a similar OD level after 12 hours, which highlights the importance of kinetic monitoring, as an endpoint read would have missed this detail, leading to the incorrect conclusion of identical behavior. To recap our findings, we were able to identify a suitable biolog synthetic media for our 6 obligate anaerobes using the anaerobic MediaMatcher plate and transfer this media to the PreBioM plate line. This enabled an apples-to-apples comparison with anaerobic growth and kinetic OD monitoring taking place on our Odin instrument. Significant substrate utilization differences were found between the 6 obligate anaerobes. Kinetic monitoring of cell growth showed the substrate's impact on the lag and log phases, giving us an unbiased view of the experiment. Understanding these substrate utilization differences can aid in engineering interactions within the gut microbiome and developing useful combinations of microbes and prebiotics. Beyond the microbiome products we discussed today, Biolog also has solutions for identification of microbes, including gram-negative, gram-positive, anaerobic yeast, and filamentous fungi. We also carry chemical sensitivity assays and support mammalian cells, including mitochondrial function. For ecological needs, our ecoplates are compatible with soil and water sample analysis. And if you have a unique use case, our customizable microplates can offer a solution. The Odin line of instruments and intelligence software supports these products, simplifying research at any scale. And lastly, should the need arise, our ISO certified lab is capable of offering our Odin-based phenotypic and ID solutions, as well as genomic sequencing and MALDI-TOF. thank you for tuning in. We hope you found this insightful and look forward to hearing how this new solution fits into your gut microbiome analysis pipeline. We will now address questions.
Thanks, Juan. Okay, so a reminder, if you have any questions, please submit them through the Q&A chat box that should be at the bottom of your webinar screen. I do want to invite you. We had some questions during the registration that came in, and one of the questions was about some of the other webinars. So I wanted to invite everybody listening to check out our previous webinars if you've missed them. biolog.com/webinars, you will find a list of previously recorded webinars. So please take a look there if you're interested. Okay, so some of the questions that we had, are the 42 media chemically defined?
Yeah, that's a really good question. Let me jump over to a slide which will help me show that. Here we go. So here we can see the different components of biolog synthetic media. And as you'll notice, some components like yeast extract, BHI, and rumen fluid are a bit complex and chemically undefined. So these components are in most of the media, but thanks to the design of experiments approach, not all media have these components. So as a matter of fact, a handful of the biolog synthetic media are chemically defined. So it's a very good
Okay,
question.
thanks. There's a question, what additional applications can biolog synthetic media support beyond the primary use that was shown here?
That's another good question. So biolog synthetic media can enable growth for larger scale experiments, such as in shake flask or small fermenters. And the cells from these experiments can be used for different omics, such as metabolomics, for example. They're very compatible. You could do intracellular, extracellular metabolomics. We've had some of our users already do this. You could also do proteomics using the cells. And it shouldn't be difficult to do genomics from there as well. So it really enables all the different multiomics related to anaerobic microbes.
Quickly, can users expect to observe measurable results with the anaerobic MediaMatcher plate?
Let me jump to a different slide for that. Let's see our growth curves. Here we go. So our experiment lasted for 24 hours. However, we were able to see results much sooner than that. As a matter of fact, we're thinking of suggesting a 12-hour analysis period, which is really where we can see most of the growth and make our conclusions. This 12 hours would greatly impact your experimental workflow, giving you a higher throughput, being able to analyze more cells during a shorter amount of time. So yeah, within 12 hours, you should be able to see results out of this.
Okay. Can we use biolog synthetic media for other applications than the biolog plates?
Yes, absolutely. Biolog synthetic media would be compatible with metabolomics assays and would be an excellent source to first grow your cells and then use them in assays provided by different vendors for whatever activity in particular you're looking for. So this could be a metabolomics assay where you're looking for different postbiotic molecules like short chain fatty acids being produced. This would be very straightforward and highly compatible with that use case.
Another one is, have you done any tests with sticky anaerobic species from the rumen? Would the plates you show work for them?
I'm not aware of any testing for that yet, but that's something that we can certainly follow up in with. So Yeah, please leave us your email and I'm happy to contact you and talk more about that and see how we can provide a solution there.
Okay, thank you. How do the plates and everything how do the plates and everything doing growth stay anaerobic? Is there a need to put the plate reader in an anaerobic chamber?
To put the plate reader in an anaerobic chamber for a 12-hour period or even a 24-hour period is not really necessary based on our results. However, for extended periods, we do expect things like effusion of oxygen to permeate uh, plate seals. So it depends on the scale of the experiment, really, what is needed. But with our protocols, you are able to take the plate outside of the chamber with a plate seal and place it into your Odin instrument for reads of up to 24 hours, which will be very similar to the results you would get from doing it within the chamber.
Yeah, and to that person who submitted it, Juan did mention that we have a special anaerobic protocols available, so that's what he's discussing here. The last one is asking about Odin. Is the Odin prone to microplate variability, such as edge effects? And is there, do you address this as any way during the data processing? I'm not sure if we have that information in the slide deck here.
Yeah, that's not something I'm really familiar with, but Odin is very robust. CVs between different replicates are quite tight. So I think it's a very robust system, which should alleviate most of these concerns. You could see this in many of our other webinars, as well as some of our application notes, with great relative standard deviation between replicates and very minimal plate effects.
Yeah, and to that person that just submitted the questions, they were submitted anonymously. If you want more details, please either share your email or your name so that we can send you more information separately, or just reach out through the info@biolog.com. Okay, I think that that should wrap up. If there's any other questions, please feel free to submit them to us through the email, the info@biolog.com. If we did not get to your question, then we will follow up separately directly with you. Otherwise, thank you everyone for joining us. Appreciate it. And as mentioned before, I will be sending out the recording in a day or so. Thanks so much, Juan.
Thank you, Kasia.